Hey, and welcome back to Science Not Silence. Last time we went over algae, and I mixed it up and was taking a look at how I could get all this stuff started. And today we're going to be talking a little bit about monitoring and take a quick check-in. It's been about 2 days since I mixed that stuff up, so let's take a quick look over what we got going so far. So this is that bottle. I mixed it up. You can kind of see some green there. So this is just from the top. But let's take a look a little bit closer, and I'll try and see if I can't get some of these swirls going. So it has been in the sunlight. I'm obviously in my bench right now, and it's been, but I've put this over by the window. I'm going to just give this a little swirl. And there we go. You can see that colony is starting to grow. Basically, nothing was really visible when this started, so that is, there's definitely stuff going there. And really, this does say, like part of the directions were shake it up regularly, and that's just to make sure the algae colony is kind of getting all the nutrients that are spread throughout the water, and just to distribute everything. Also to get more sunlight if it bunches up like this. This is basically just from gravity, I think. So taking a look there. So not huge growth yet, but we'll get there. It's so just well, there they go. Grow, little algae, grow. All right, so what I wanted to talk about today is starting to measure some stuff on here. So with algae or with any kind of biological process like this, there are certain standard things that we can measure there. And so some of them are temperature, the pH of the water to see how things are changing over time. Part of the salts that we added were actually to make it more alkaline, which is more basic, I think. So I would imagine if we charted pH over time with a brand new colony, we'd see the pH would be higher, right? Higher pH is more basic, lower pH is more acidic, and over time we'd see it start to dive back down towards 7, right? So 7 would be that's the neutral pH, as far as I know. Still learning this stuff. Another thing, though, is just electrical conductivity, which is basically, well, let's take a look. It's electrolytic conductivity. I think it's basically how many salts are it's measuring the conductivity of the water itself. So let's take a quick look at, there's some wiki pages here. So there's conductivity, electrolytic conductivity, and there's also pH, and you can read all about this stuff. And then other things you'd want to measure are like temperature. And that's another thing that is very standard, just wanting to see temperature, maybe charting it throughout the day. And eventually, I'd like to also have CO2 measurement, right? So actually measuring the CO2 above the water, because the whole goal of this is to see, is this actually capturing carbon? Is it capturing the CO2 out of the air, basically? Which you'd imagine in any kind of photosynthesis process that would happen, but I don't know. I'm guessing that's also part of the, agitating the bottle is also, bringing more CO2 bubbles down into the water so that it can help the photosynthesis process. Again, still learning. So, but what I did want to show is that there is a tool that my friend and a member of Contextual Electronics, which is the course I build, she was building a lot of this stuff for hydroponic measurement, so growing herbs and lettuce and all that other stuff. And Margaret has been doing great stuff here. She actually finished a design, and I helped work on this thing. So this is basically all on GitHub, and just wanted to take a quick look at it here because this is something that I think that I'm going to be building as, so part of what I do is I build stuff for electronics on Contextual Electronics, and I'm going to probably bring in this project and actually use it as a example here, but then actually use the output and measure and stuff like that. So this is the latest one that she builds, called the Ladybug Blue. There's also the Ladybug Shield, but basically it's a bunch of op-amp circuits that can then go out and measure probes here, pH probe and an EC probe, and in doing so, you can basically have access to a lot of them. There are existing circuits out there, but basically you can buy these probes, and then you can also buy the measurement circuits, but this kind of integrates them all on one thing and adds it to a data logger via a Bluetooth module. And if we take a look, this is all the modules aren't necessarily turned on here, but where is it? View 3D model. It just kind of it looks like this. Basically, you can see there are some BNC connectors here, and then there's some SOICs that are the measurement circuits, and then finally there's also some FETs here, or maybe they might be Darlingtons actually, but basically to turn on pumps in order for the system that she was building, the hydroponic system, all controlled by Bluetooth. So what I'm probably going to do is take some of this circuitry here and then integrate it into another thing. But I just wanted to show that here. That'll all be part of contextual electronics, or over on contextual electronics. Science Not Silence, we're talking about the experiments, but any part of science is basically making sure you're able to actually measure all these things as well, right? So it's important that you can actually monitor throughout time. That will be, kind of a corollary to all the actual science discussion that we're having here. Like I said, to reiterate, I am learning all this stuff as we go along, and that's kind of the point of, Science Not Silence is as an investigation into all of these citizen scientist type things. But in doing so, it also will, kind of feed into my electronics hobby and my electronics business. And so if you want to take a look over there as well. So just wanted to take a look at that. We will be measuring pH, EC, temperature, and then eventually on a separate board probably CO2 as well. There's a couple CO2 sensors out there. So if you have any thoughts, do you have any questions, hit down in the comments below, where I'll also put links to those wiki pages. Thanks for watching. See you next time.